Hello, today I'm going to be explaining the biomechanics of a goal kick in soccer, which is a method to resume play after the ball went out of bounds near a goal. It is usually taken by a defender or goalie, and their mission is to kick the ball for maximum distance to a player on their own team. To begin, I will be explaining the joint movements and the muscles that produce and control those moves in each phase of the skill. During the approach, the kicker should first be about 5 to 6 steps away from the ball, and then move towards it at a 45-degree angle. This allows the lower limbs to reach maximum velocity or speed, and then exerting max force on the ball. The pre-impact phase consists of the non-kicking leg placed near the ball for support and to properly transfer momentum. During the backswing, the glute and deep six rotators allow for hip extension and external rotation, quad muscles allow for knee flexion, ankle joint plantar flexes the foot due to muscles in the calf, also known as the gastroc and soleus, and lastly, opposite shoulder abducts for stability. During the forward swing, hip begins lower body movement by flexing and internally rotating the thigh using the hip flexors. Knee then causes lower leg to extend using hamstring muscles, and ankle continues to plantar flex the foot. During the impact phase, the foot briefly comes in contact with the ball for about 0.1 seconds. Foot must stay firmly plantar flexed, and the change from eccentric to concentric action helps hip flexors produce more force by using stretch to shorten cycle. Lastly, the body continues to move after contacting the ball. The follow-through phase consists of the legs slowing down by hip flexion and internal rotation, knee extending lower leg, ankle dorsiflexes the foot by using peroneus and anterior tib, and arms adduct. Proper follow-through consists of leg naturally swinging upwards as high as it needs. This is important for injury prevention by ensuring that knee doesn't hyperextend or muscles and upper leg don't strain. Next, I will discuss how applying physics can allow the kicker to have a deeper understanding on how to maximize the height, distance, and velocity of their kick. When a ball is kicked, it moves through the air as a projectile motion, coming down to the ground due to air resistance and gravity. A goal kick's distance relies on 3 factors: the moment of release of how and where it was kicked, initial speed, and angle of projection. Our leg acts as a third-class lever at 3 different joints. These joints act as the fulcrum, our muscles cause the effort, and the resistance or load is due to the soccer ball. A short lever applies greater strength and force, while a long lever allows for greater speed and velocity. Torque is the rotational effect of a force. When kicking, we can see this happen twice. Our intervertebral joints in the spine causing our upper body to rotate, and also our hip and knee joints causing our hamstrings to exert torque around the knee, helping transfer the most momentum into the ball. Newton's laws of motion can be seen during the impact phase. The first law states that an object remains in the same state until acted upon. For example, the ball stays grounded until our kick acts on the ball, changing its state. According to Newton's second law of motion, the force applied to an object affects its acceleration or change in speed. This is seen when the ball suddenly accelerates when the ball is kicked and force is applied to it. Lastly, the third law states that there are equal and opposite reactions when a force is applied. So although we can't feel it due to our mass and velocity, the ball is exerting an equal and opposite reaction when we kick it. Momentum is the force we have when going through a motion. We have linear momentum that is seen from the approach and continues until the follow-through. Our mass and velocity when going through the phases allow us to exert the most force on the ball. The angular momentum is the same as linear momentum, but is caused by the torque mentioned previously. Impulse is defined as a change of momentum. This can be caused when the backswing of a kick doesn't use full joint range of motion, thereby decreasing velocity and strength of kick. So increase in impulse will lead to increase in force exerted. Lastly, the projection angle or angle at which the ball leaves the floor is critical to the distance and height of goal kick. Optimal angle of projection should be near 30 degrees. Anything less will cause the ball to not reach sufficient height and distance. Proper projection angle depends on how and where the ball was kicked, so the ball should be kicked at the bottom half using the laces part of the shoe. So overall, several components go into performing a proper goal kick with maximum force. Components such as full joint range of motion, muscle strength, velocity, momentum, and so forth.